So in our previous class, if you remember, we introduced the concept of chemical equation, the meaning of chemical equation, the parts or the subdivision of a good equation, and how a good chemical equation can be balanced. So today we want to look at some examples to solidify the knowledge base we have built in our previous class. So the question, there are some questions on the board. The first one states, write the correct equation for each of the following. The correct equation. So the first question is the reaction between sodium metal. Sodium metal is Na, solid, because the state of the reactant and the product are also very, very important. You have to put them there. It is part of the mark that will be awarded when this type of thing are being marked in any of the public examinations. So sodium metal is solid, and oxygen gas plus O2, which is what? Gas. The state is gaseous. It is gaseous state. So directly, sodium will combine with oxygen gas to give you not some students are still writing NaO2 because they saw maybe because O2 is the oxygen is carrying just two atoms here. So they just combine sodium directly with oxygen to now go and write NaO2. Is very, very wrong. That is why I said that the knowledge of correct formula is still very, very important here. So when sodium combine with oxygen, the correct formula is Na2O. Very, very important. Na2O. If you remember, sodium belongs to group 1, oxygen belongs to group 2. So they exchange their valency. 2 go to Na, 1 go to O. That's why it is Na2O. So don't say it is NaO2 because that is the way you have it in the equation. No, the knowledge of correct equation must still come to bear in this type of topic. So sodium combined with oxygen directly to give you Na2O, sodium oxide, to give sodium oxide. Sodium oxide. So then let us look at it if it is balanced or not. The number of atoms of sodium is 1. The number of atoms of sodium on the right hand side is 2. So definitely the first thing that must come to your mind is that you have to put 2 in front of sodium. When you put 2 in front of sodium, then you now have sodium to be 2 on the left hand side, 2 at the right hand side. Oxygen is also 2 at the left hand side, but it is 1 at the right hand side. So there is still problem with oxygen. So the right thinking students should know that the next thing to do is to put 2 in front of sodium. Although it is increasing the number of atoms of sodium, but don't have to bother with that. First of all, try it. If it is not going to work, then you can clean up. And when you are doing this type of you are trying to balance equation, start with your pencil. Especially if you are writing it in an exam, because there will still be need for you to clean or cancel any of them at any point in time. So when you put 2 in front of sodium, then that 2 now, because it's also going to affect oxygen, so oxygen atom is now 2 here. Oxygen atom is 2 at the other side. But sodium has become 4 at the product side. So the next thing for you to change 2 you have in front of sodium to 4. That makes it a balanced equation. So you now have sodium to be 4, oxygen to be 2 at the left hand side. Sodium is 4, oxygen is 2 at the right hand side. So that is a balanced equation. For the number 2, the reaction between hydrochloric acid and sodium hydroxide. So hydrochloric acid is HCl, hydrochloric acid. And anything acid you must start with is hydrogen, H. Any acid will start with hydrogen atom. Even if it is tetrasulfuric acid, H2SO4. So hydrochloric acid, and the state is aqueous. And let me also remind you there that anything that you are going to use aqueous for must be either acid, base, or salt. Acid, base, and salt we always have aqueous state. Aqueous state. Don't forget that. So since we are talking about hydrochloric acid, so you put aqueous plus sodium hydroxide is a base. It's also going to be aqueous. Sodium hydroxide is NaOH. I believe you know the reason why it is NaOH from our previous class. The correct formula. Sodium belongs to group 1, and hydroxide belongs to hydroxide is a radical valency of 1. Sodium valency of 1. So the two cancel that. That is why it is NaOH. NaOH aqueous. Aqueous. It will now give you. This is where the first technical issue comes in the writing of correct formula. Now, I want to give you a simple law that will guide you to write correct formula at any point in time. A simple law, although we don't have it in most textbooks. It's a research that I've sat down to study and look at many times. That when you have this type of reaction, always know that metals will attract non-metals or radicals. Let me write it somewhere. Metals attract non-metals or radicals. Don't forget that. If you can remember these simple rules, you will not have problem in knowing what goes for what to get the product. Metals always attract non-metals or radicals. So if you look at, going back to the example we are treating, hydrogen belongs to group 1. Although it's not really a metal, but in this type of compound, it is representing a metal. It belongs to group 1. So it is expected to attract a non-metal or radicals. On the other side, in the second reactant. So therefore, H goes with OH, which is radical, metal to non-metal or radicals. So therefore, that becomes what? Or let's look at the first one. Sodium belongs to group 1. It's a metal. It's a direct metal. We go with non-metal here. So that will now give us sodium chloride. NaCl. Na plus Cl, because chlorine is a non-metal, so it will attract sodium, which is a metal. That will now give you sodium chloride. And the correct formula of sodium chloride must also be, you must make sure that you write it carefully and correctly. So NaCl, not Na2Cl or NaCl2. It's ordinary Na, because this have valency of 1, this have valency of 1, they cancel out, become NaCl. So NaCl, what will be the state of NaCl? I said the other time that any acid, base, and salt will be represented with what? Aqueous state. So since sodium chloride is a salt, so the state will also be aqueous state. Then the last thing, look at what is remaining. Sodium is out, chlorine is out. What you have remaining in the reactant side is hydrogen and OH. And an intelligent student should know that when you have OH coming with hydrogen, water is going to come out. So the last thing will be H2O, which is a liquid state, water. Are you getting it now? So the next thing is to look at if it is balanced. Two hydrogen at the reactant side, 2 hydrogen at the product side, 1 chlorine at the reactant side, 1 chlorine at the product side, 1 sodium at the reactant side, 1 sodium at the product side, 1 oxygen at the reactant side, 1 oxygen at the product. So it is balanced. You don't need to add any number. So it's already a balanced equation. It's a balanced equation. It's a balanced equation. It's a balanced equation. So thank you. We continue from there.